Okay, so for this next video, we're going to talk about just finding the slant asymptote. So, we've seen this slide in some of the previous videos, and kind of focusing here, we know when it comes to horizontal asymptotes, we have a horizontal asymptote if the denominator has a bigger degree or the numerator and denominator have the same degree. So we've kind of seen this, but we haven't seen what happens when the numerator has the bigger degree. That is going to be a slant asymptote, and we are going to do synthetic division to find this. So we'll have to refresh ourselves on that. Okay, so all we're going to focus on for this day 9 video is just finding the slant asymptote. The next 2 videos, we'll go through graphing them. So when I look at this, it's real easy to tell the degree of this numerator is 2 and the degree of the denominator is 1. Since the numerator has a higher degree than the denominator, this is going to be a slant asymptote. So we do synthetic division to do this. So I'm at fractions or division, so I'm actually going to do this division here. So this is what I'm dividing by. So if I were to set that equal to 0, I get x equals -1. So that's what goes in our little box. And then remember with synthetic division, you just put all these coefficients. So the coefficient in front of x squared is 1, in front of x is 2. We have no constant, but we need to add it there. So I'm going to add it like so, and I'm going to do my synthetic division. So here we go. I bring down the 1. -1 times 1 is -1. Add down. I get 1. -1 times 1 is -1. I add down and get remainder 1. So with slant asymptote, we don't care about that remainder. All I care about is this part right here. So if I were to place this in a polynomial, I would get x plus 1, and there's our slant asymptote. So when we go to graph this, we'll have to remember, I'm going to go ahead and do this part with you, but that is a slant asymptote. This is in mx plus b form, so that plus 1 is our y-intercept, and then we have a slope of 1, so we got to remember rise over run. Up 1 over 1, and that is how our slant asymptote is going to look opposed to horizontal. Okay, but you'll get more on that with the graph tomorrow. You could do long division here. If you remember long division and you want to go back to that, absolutely, but I feel like most people opt for synthetic division. So whichever route you want to take, you'll get the same thing. The main thing is we don't care about the remainder. Your slant asymptote will always come out in the form of y equals mx plus b. Okay, let's try this next one. Now this one, remember we can only do synthetic division when it is a linear, when you're dividing by a linear binomial. So for this one, we're dividing by a quadratic trinomial. So if you have something like this where you see that you have the bigger degree in the numerator than the denominator, we probably have a hole in the graph. So let's first take a look at that. I am going to start by GCFing out an x here in the numerator, so I'm going to factor this out. I'm going to factor the denominator. That's going to become x plus 3, x plus 1. Factor this trinomial. That's x plus 3, x minus 2. Okay, so I've completely factored the numerator and denominator, and I can see, yes, in fact, I do have a hiatus point here, a hole in the graph. So you would have to find that. So this is just a little review on how to find the hole in the graph, even though the directions are just asking for the slant asymptote. If I were to set this equal to 0, I would get x is -3. I am going to rewrite this problem, and I'm not going back to the original problem. You remove the hole in the graph and don't go back to it. So ignore that. So to find the y for the hole, we would plug it in for all the x values, and then that would generate the y for the hole in the graph. Okay, so that's just a little review on the hole. The purpose of today's lesson is finding the slant asymptote. So let's go back to this. I know that this is going to have a slant asymptote because the degree of that numerator is 2 and the degree of the denominator is 1. So the numerator has a higher degree than the denominator. So I got to do synthetic division. I actually have to multiply this back out to do, whether you do synthetic or long division, you're going to have to multiply that back out. You don't want it in factored form. Okay, so from here, I am going to take this and set it equal to 0. And okay, so I set this denominator equal to 0, and I get x is -1. That's what goes in my box right there. And then I use all my coefficients, 1, -2, and we do have an understood constant there, so I need to put a placeholder. Oh, I don't need to do plus. Okay, 0. Okay, let's do our synthetic division. Bring down the 1. -1 times 1 is -1. Add down. Multiply 1 and -3, and I get 3. My remainder is 3. Remember, we don't care about the remainder. We just care about this part over here, and that's y equals x minus 3. There's our slant asymptote. And just a review on how to graph these. This is it. This is always going to be an mx plus b form. That is our y-intercept at -3. Your slope is 1, so you go... Okay, so the y-intercept is -3. Our slope is 1, so that's rise over run. So you go up 1, over 1, up 1, over 1, and you get your slant asymptote. So we'll get more with that tomorrow, but one more example here. So when I look at this, the degree of the numerator is bigger than the degree of the denominator. So we are going to have a slant asymptote. So to find this, we're going to do synthetic division. So I'm going to start. I know that if you were to factor this, there's no hole in this graph. So we can go straight into doing the synthetic division. If I set that equal to 0, I get x equals 2. So that goes right there. List all the coefficients out from the numerator. And let's do our synthetic division. Bring down the -2. 2 times -2 is -4. Add down. 2 times 3 is 6. Remainder 1. Again, we don't care about the remainder. If it went in evenly, that would mean it was a factor, and then you'd have a whole to cancel out. Okie doke. So y equals -2x plus 3. There's our slant asymptote. I'll just put it on a graph real quick. So this is our y-intercept. And then our slope is -2. That means down 2 over 1, down 2 over 1. And so there we go. There's your slant asymptote. So now go to day 9's worksheet and complete just the finding the slant asymptote. Day 10 and 11, we'll get into actually graphing these. So have a great day.